Imagine the most perfect, infinitely detailed pattern in all of mathematics, then imagine it breaking. What if the very fabric of mathematical beauty suddenly glitched? For decades, the Mandelbrot set has stood as a monument to infinite complexity, a mesmerizing world born from a simple equation. It's a universe of endless spirals and budding forms, always predictable, always following its rules. But deep within its intricate tendrils, far beyond what most eyes have ever seen, lies something that shouldn't be there, a sharp, geometric anomaly that screams error, in a place where errors are simply impossible. This isn't just a strange pattern, it's a profound mathematical mystery, a digital scar on the face of infinity. The Mandelbrot set itself is born from a straightforward idea: take a number, square it, then add the original number back. Do this over and over, and depending on whether the result flies off to infinity or stays trapped, you color a pixel. The equation z equals c squared plus c creates these breathtaking landscapes. It's a deterministic system. Put in the same numbers, you get the same result every single time. It's infinitely detailed, meaning no matter how far you zoom in, new patterns emerge, yet it all remains connected and predictable. That's why this set is such a comfort to mathematicians and artists alike. It's a perfect universe governed by perfect laws. But then came the glitch. It was first spotted not by a university professor or a supercomputer, but by amateur fractal explorers pushing their rendering software to extreme zoom levels, sometimes billions of times in. They were looking for new, organic beauty, but instead, they found something alien. Instead of the expected smooth curves, delicate tendrils, or mini Mandelbrots, there was a blocky, angular intrusion. A series of perfectly straight lines, sharp corners, and pixelated squares, sometimes appearing like a tiny, misplaced QR code or a sudden tear in the fabric of the fractal, appearing precisely at coordinates around, say, minus 0.7436447860. Plus 0, 131, 885, 8348, I, when rendered to absurd precision. It's like finding a brick wall in the middle of a natural coral reef. Naturally, the mathematical community tried to explain it away. One idea was that it's just part of chaos theory at play, but the glitch isn't chaotic, it's rigidly structured, too ordered to be random noise. Others thought it might be an edge case, a bizarre but legal outcome of the equation at extreme values. But careful analysis showed that the core z equals c squared plus c equation, when calculated with enough precision, simply doesn't produce these kinds of sharp, non-fractal shapes. The most common technical theory points to floating point limitations, that computers just can't handle such tiny numbers perfectly, creating rounding errors. Yet, when developers use specialized arbitrary precision libraries, capable of calculating with hundreds or thousands of digits of accuracy, the glitch persists. It doesn't go away with more precision, it just becomes sharper, more defined. It's not an artifact of our tools, it's an intrinsic feature. This persistence has sent the imagination soaring. The online community, from Redditors to Discord groups, has flooded forums with wild theories. Some propose it's a simulation error, in the very fabric of our reality, a little digital hiccup that accidentally bled into the Mandelbrot set, our universe's own blue screen of death. Others suggest it's evidence of an undiscovered formula interacting, a secondary mathematical law or a hidden dimension subtly influencing our familiar equations. Perhaps an interdimensional bleed-through, where another mathematical space is subtly overlapping with ours, manifesting as this jarring intrusion. It's less scientific, sure, but how else do you explain something that breaks all the known rules? If this glitch truly isn't explainable by existing math or computational limits, it's not just a curiosity, it's a paradigm shift. For mathematics, it could mean that our understanding of fundamental operations isn't as complete as we thought. It could hint at new number systems, new types of geometry, or even entirely new theories of computation. For science, it could be a clue about the hidden architecture of the universe itself. And for art, it It opens up a new realm of surrealism, a profound reminder that even in the most beautiful and perfect systems, there can be unexpected, almost supernatural, imperfections. It forces us to ask, what other glitches are hidden in plain sight, waiting for us to zoom in just far enough? What do you think this glitch is? Share your craziest, most scientific, and most plausible theories in the comments.